Question 4. A player rolls a fair dice and simultaneously tosses a fair coin. A dice and a coin. If the head appears on the coin, if the head appears on the coin, then the player wins twice the value that appears on the dice. However, if the tail appears on the coin, if the tail appears on the coin, then the player wins half of the value that appears on the dice. What is the player's expected win? So first of all, we need to write the sample space, or we can say all the possible outcomes that are possible. Suppose head appears on the coin and 1 appears on the dice, or head appears on the coin and 2 appears on the dice, or head appears on the coin and 3 appears on the dice. Likewise, we can write h4, h5 and h6. Now suppose tail appears on the coin and 1 appears on the dice. We can write it t1. Tail on the coin, 2 on the dice. Like this, we can write t3, t4, T5, T6. So these are the values that can appear in this experiment. So if head appears, then whatever value is appearing on the dice, just take the twice of that value. So if 1 is with head, make the twice of it. If 2 is with head, make the twice of it. Like this 6, 8, 10 and 12. Now the question says that if tail appears on the coin, then half of the value that appears on the dice. So if 1 is appearing on the dice and tail is appearing on the coin, then take half of the dice value. So if we have 1 on the dice, we can take half of this value. If we have 2, we can take half of this value. If we have 3, we can take half of this value. Half of this value, half of 5 and half of 6. Now, suppose this is the amount 2, 4, 6, 8, 10. These are the amounts. So, suppose this is the amount x. Now, what will be the probability? So, probability of this h1, probability of h1, probability of appearing head on the coin is 1 by 2, and probability appearing 1 on the dice is 1 by 6. So, this will be 1 by 12. What will the probability of h2? Probability of h2. Probability of h is 1 by 2. Probability of appearing 2 on dice will also be 1 by 6. So this will also be 1 by 12. So we can see that the probability of all these 12 outcomes will be same, that is 1 by 12. So we can write that probability of all these 12 outcomes will be 1 by 12, 1 by 12. 1 by 12, 1 by 12, 1 by 12, like this one. All probabilities will be equals to 1 by 12. Now, we have random variable x and corresponding probabilities. We have random variable x and corresponding probabilities. So the question is saying what is the player's expected win? So we need to find the expected value of x here. Okay, so what we have, suppose we have probability distribution of x in discrete manner. Suppose x is taking three values x1, x2, x3, and corresponding probabilities are p1, p2, p3. Then how do we calculate the expected value of x? We multiply x1 with p1, multiply x2 with p2, multiply x3 with p3, and then take the sum. How? X1 plus p x1 into p1, x2 into p2, x3 into p3. That means multiply the values of x with corresponding probabilities and then take the sum. Similarly, here we can multiply this 2 with 1 by 12, this 4 with 1 by 12, this 6 with 1 by 12, this 8 with 1 by 12, and take the sum. So we can write like 2 into 1 by 12 plus 4 into 1 by 12 plus 6 into 1 by 12, like this one. We can take the sum of products till here. 2.5 into 1 by 12 plus 3 into 1 by 12. Now, this 1 by 12 is appearing in every term, so we can take it outside. Then we will be remaining with 2 plus 4 plus 6 up to 2.5 plus 3. Okay, so what is the sum of these x values? 2, 4, 6, 8, 10. Let us take the sum. This will be 6, 12, 20, 30, 42, 43, 45, 48. Now take the sum of fraction part, 0.5, 2 and 4.5. So this will be 1 upon 12 into 52.5. Now if we divide it, we will get 4 point. So only option D has D have 4, so option D will be correct. So the final value will be 375. Option D is correct. The expected value of players win is 4.375.